Hello, game freaks! So we have already created one regular tile map using Godot. Now today we will see how we can create an isometric map. And we also have a wolf which is moving in four directions. Now if you carefully see, this is not really up, down, left and right. This is more like diagonal movements. And because this is isometric map, this looks perfect. However, we will also see that how using our mouse we can actually move in any direction. The animation may look a little bit weird because we only have 4 direction animations, but yeah, using a more detailed sprite sheet, this can be taken care of. And lastly, we will also create a randomizer which will generate random maps. We have already done it using our regular tiles, and today we will learn how we can do this using isometric tiles also. And this is actually very simple. So let's open Godot and let's see how we can build this. So first things first, I would like to show you what are the assets I'm using for this video. And this is the 32x32 isometric tiles that I am using. And here we have terrain tiles and we also have the wolf tiles. Now you can also use the boar or the deer or anything else. But yeah, I would like to keep things simple. I will use the wolf and some grass and maybe water tiles. So let's get back to our Godot engine and let's see what we can do with this. So here I will create a new 2D scene. And in the 2D scene, what I want to do is like any other map, I will open a tile map layer. So this one. And here, what I want to do is I want to create a new tile set. And now we will have lots of squares. Now, the issue with this is like a regular tile map. Now we don't want a regular tile map. What we want is something like an isometric tile. So what we can do is we can click on the tile set and here we have the tile shape as square. We can simply change it to isometric. And now we have something like diagonal squares. But this is still fully not isometric. Now let's first see what we can do with this. So what I will do is I will import my assets. So here I have downloaded many assets and we are using the isometric tile. So now this is our isometric tile set. And this one basically contains everything. So all of our basically terrains. So let me just drag it and import it here. It is at the bottom, I'm not sure why. So let's just keep it here. And we will also import our wool. So our wool will actually be inside the critters. So we will come inside the critters. In the critters, we have a wolf. And here I will take the idle one and the wolf run. So if I just zoom in this one, so this is the idle animation and this is the running animation. Now why I'm using the wolf and not any other animals is because you will see, for example, the stag. The animations are fine, but we have to import a lot more things. Now I want to keep things simple for this video, so I'm just using the wolf because I can get many things in one. But yeah, for your own game, you can definitely use anything that you want. So let me go back to my wolf, and let me just take these two images and let me import it here. I think it's imported somewhere down. I'm really not sure why these things happen. I am trying to import it inside the assets folder. But yeah, anyway, so now we have these things. So what we want to do is we want to see, let's like what we can do with our tiles. So inside the tile set, I will import my isometric tile. So where is my isometric tiles? What was the name once again? I think this one. Huh? Let's check once again. What was the name? Isometric tile set. I think this is called sprite sheet only. Yeah, so this one. So let me just drag it here. Yeah, I will automatically change things. Now here there is a little bit of an issue, and that is since this is not a regular tiles. There is some mistake. So these small squares are actually taken as one tiles, but I don't want that. What I want is it should be 32 for the width as well as 32 for the height. So I want this whole thing to be one tile. So now if I go to my tile map and if I let's say take this grass and if I try to draw it, it will look something like this. Now the sizes are not very consistent as you can see, and these things are getting stacked on top of each other. So let's see how we can make it look better. So it is definitely something related to our size. So we are here drawing 32x32 inside a 16x16, and that is the main problem. So we can make it 32 and 32. And now if I just take this one and try to draw it here, things will look better. So tile map, this one. So now these things look better, but there is a problem with the alignment. And so what is really the issue? So we really don't want our tiles to look like this. So what we have to do is something little bit odd. So although our width is 32, our height should actually be less than 32. It should actually be 16. And if we then try to draw it, it will look much, much better. So for example, if I just make it 16, as you can see, it is still not the best look, but it is kind of getting there. So if I, let's say, use these tiles, and if I just take it like this on the other direction, or let's say in this direction, as you can see, it looks little bit like steps, but yeah, it is better than what we had last time. So for example, as you can see, we can create maps. Only issue is it is forming steps. We don't want that, so let me just remove everything. So fixing this is actually very simple. Here there is something called tile layout, and here we are taking a stacked. What we have to do is we have to take the diamond down. And now if we try to draw our grass, let's say this one, and let's try to draw it. And as you can see, this looks perfect now. Let's try to draw more. And this looks very good. We can take some other kinds of tiles also and keep it here and there. We can take some water tiles also. I think below we have some water. Let me take this one, and I don't want the camera or anything else to change. So this is how our water looks like, kind of like the intro that I have shown you. Now inside the water, I can also put some rocks or something like that. So something like this. Now we don't really have trees or anything else here. We have some grass or some flowers, but we don't really have trees. So maybe we have to draw some trees to get our trees and other things. But yeah, you kind of get the idea that how we can make isometric maps. Now, the next thing that we have to see is how we can import our player and move around. That is actually very simple, but our animations will look a little bit weird. So, for example, we already have a player from our RPG game. So, where is our player? Our player will be inside my scenes, and here is our player. Now, if I bring on my player here, so our player is here, and if I also get a camera 2D, let me take it 4 cross 4. And now, if I run the node 2D, okay, I have to save my scene. It is not yet saved. So this is isomap. Let me save it isomap. And inside my scenes, I will save the isomap. Now, if I run the isomap, what will I get? I will get my player in the isometric map. Now, her movement looks a little bit weird because isometric maps are not top down, left, right. It is more diagonal. And so a better character would be our wolf. So let's remove our player from our scene. And we have to create a new scene. And we will use a character body 2D, and we will add an animated sprite 2D, and we'll rename the character body 2D to wolf, and let's save the scene. So inside our scenes, I will save the wolf scene. Now in the animated sprite 2D, I have to import some sprites. So new sprite frames, and here we have a default. So I will name it as idle or wolf idle, let's say. And I want to import our idle wolf. Now our wolf has idle in 4 directions, but for simplicity, I will just take one for now. So this is our wolf. So how does it look? If I simply play, so this will look like, yes, very simple idle animation. Now we have to add few more. So I will add another animation, and this will be basically our run. So we have to make 8 divisions in the horizontal. And so this is basically running in the southwest, right? So we'll run SW. Another one will be will run southeast. Another one will be will run northeast. And the last one will be our northwest. So will run northwest. Now these directions are according to our point of view. In the map, this is actually this may not be these directions because isometric maps have little bit of an angle, so it will happen accordingly. So this is our southeast movement, I mean southwest movement. So let's add the southeast one. This will be this one, add 8 frames, and we will have this. So let's add the northwest. Northwest will be this one. We have this one, and we have a northeast. Northeast is the last one, which is this one. Great. So we have a four sprite idle, and this will be an autoplay. So now if I simply run our wolf scene, nothing will happen, I believe. No, our wolf is at the corner. So what we can do now is in our ISO map, we can import our wolf. So let's import our wolf, and we will also add a camera. So there is an error because our wolf doesn't have any collision, which is fine for now. We are trying to understand how our movement will work. Now, if I run the ISO map scene once again, we have our wolf at the center, and our wolf is idle. Now we are of course not really moving because we have not added any code for the movement. Also, I will zoom in our camera to do. So for adding movements, what we have to do is we have to add a script, and I will save my script inside my scripts. So the script will be wolf, which is fine for now. And this inherits character body 2D, and I want a default node. I don't want any predefined code. So let me just create it, and we have an empty character body 2D. Now we kind of have an idea of how movements code works. So if I go to my player, we have some predefined speed, and we have a player movement function which is basically changing our animation types, like our animation modes, and then we have physics process and player. So player is basically to check for other things, for collectibles and other things. And in the physics process, we are basically calling our player movement. This is a very simple code, and this is something similar that we have to add for our bull. Now there will be one difference although, and that is our bull will have two direction speeds. So speed x is 200, and let's say that speed y, this will be 100. Now why is there a difference? This is because when we have our regular player, for example, for her case, she is roaming around in a world of squares. So she has two direction movements, and both can be equal. So we can have one speed. But for our wolf, if you can see in the ISO map, we have um, we have isometric tiles where the width is actually longer than the height. So it is 32 cross 16. So we cannot have equal speed in both directions. That will cause a problem. So this is the reason our wolf will have one variable speed x and another for the speed y. Now we will also have a func player movement, and inside we will have a delta as usual. Let me write a pass for now, and then we will also have another function for the physics process, so func physics process, and inside we will call our player movement, and we will pass the delta. Now, whenever our player is ready, we don't really have to do anything. So I think this can be as it is for now. And for our process, we don't really have to do anything here. So we can keep as it is. So what we have to do is basically inside our player movement. So what do we need to do? We need to change our animations according to different modes. So we will first check if input dot is action pressed, and we will check what are we pressing. So we will basically press like our arrow keys only, and depending on our arrow keys, we will move in several directions. And instead of a just pressed, I will simply add is action pressed. So UI right. So this is our right direction. In this case, what we want to do is velocity dot x should be our speed x, and a velocity dot y should be our speed y. And that's not all. We also have an animation sprite 2D. So animated sprite 2D. So this will change our mode of animation. So whenever we are pressing right, let's consider we want to move towards northeast or something like that. So wolf run any. That is what we want. Now let's say we only have this much. So what will happen if I just run the game now? And lastly, we have to do a move and slide. This is required for our game to work. So in our ISO map, we have the wolf. Let's run. And if I press right, as you can see, um, we are moving. Now this is an infinite, like it's not stopping, and that is a problem. And that is because we are not really taking care of the idle and other cases. So if this is the situation, and this is what we will do. Else we will do an animated sprite 2D dot play. This will be idle, and our velocity dot x should be 0, and a velocity dot y should also be 0. So this will take care of it. Now the more important thing is, I think this direction, this animation doesn't really look good. I think there is an issue with our animated sprite. Looks like, so run northeast, it should look like this. That is fine. Northwest is like this. Southeast and southwest. The main issue is, I think, the velocity y should actually decrease, because the more we go up, the value of y actually decreases. So now if I run once again, at least our northeast movement should work perfectly fine. And we are basically not changing to our idle animation. And that is because it is actually wolf idle, I believe, and not only idle. So in our wolf, I will, uh, what is this wolf? And this is actually my player, my bad. So I have to check my wolf. So if I go to my wolf, I have one direction movement. Now I have to add the others. So this will be mostly similar. In place of the if, we have to write elif. And remaining things will be mostly similar, only the directions and the animation names will be changed. The variables and functions remain the same. So if I am pressing right, I am going to the northeast. Now if I'm pressing left, where should I go? I should go to southwest. Little bit tricky, but that is where we should go. We should go to southwest. So the directions will change totally. This will become minus and this will become plus. Now if I'm pressing up, I should go to northwest. So northwest means both x and y values will decrease. And if I am pressing down, I will go to southeast. So this will be southeast and both will be a plus. And now we will have a very beautiful wolf animation. So in my ISO map, let me just run my scene once again. And I have 4 direction movements working perfectly fine. Now in our intro, we have seen one more thing, and that is by mouse click. Oh, I think this needs to be fixed. And this is actually very simple. This is not really the idle. I think this is the wolf idle. There is nothing called idle here. So wolf idle, yes. Now this will work perfectly fine. So let's restart our scene once again. So our wolf is in idle. It is running and it is becoming idle. So it will become idle in this direction every time. We can make it 4 direction idle also. But yeah, that is not the goal of this video. The goal of this video is to learn more about isometric maps. So we have a player moving perfectly fine in our ISO map. Now what we need to take care of is how, by clicking the mouse button, we can move in any direction. Right now directions are fine, but that will be even better. And to do that, we have to come to our wolf script once again, and we have to add few more variables. The first thing that we need is a target position, and we'll initialize it to null. And we need another thing, and that is called a move threshold. What this means is, um, we will consider that our player, and that is our wolf, has moved to the new position if the new position is within 3 pixels of the point where we have clicked. So this is our move threshold, and our target position is basically if we have a selected position or not. That's all. Now inside my player movement, for our mouse click movement, we have to check if our mouse is clicked or not. So we'll do an input dot is mouse button pressed. Then we will check if it is the left mouse button or not. So mouse left. If this is true, then what we have to do is in our target position, which is initialized to null, we have to give it some value and we'll get the current global value. So get global mouse position will assign this value to the target position. Now the next thing that we have to check is if target position is not null, then what we can do. So our target position initially will be null. If we are not clicking the mouse on the screen, our target position is null. Otherwise, our target position is not null. So whenever our target position is not null, our player should move according to our mouse. Otherwise, if we press our keyboard keys, our player can move. So this is basically what we are checking here. So in the if condition, we are checking the mouse movement, and in the else condition, we will check our keyboard movements. So all of the code for our keyboard that we have written just now, this should be moved inside the else. Something like this. The if needs to be correctly placed. I think the whole everything has an indentation issue. Yeah, so I think this is fine. Now inside my if, when the target position is not null, we have to see what we can do for the mouse movement. So we will need few more variables. One is the direction. So this direction will be helpful in determining which animation we should play. So this will be target position minus global position. Global position is already there. There is nothing that we need to take. We need to define or anything. So this is like basically the global position. Target position is where we are going. The global position is where we are. That's the difference. And then we need to calculate the distance also. So the distance will be global position dot distance to our target position. So target position. Yeah. Now, finding out like which animation to play where is a little bit tricky because here we are moving in four diagonals. I mean, everything is sorted here, but here we have to kind of think that how we can get the correct animation. So how we will do it is something like this. If distance first of all is less than move threshold, in this case, we should be idle. So because if this is less than 3 pixels, we will consider that we have already moved there. So the target position will once again be null, and we can do a dollar animated. I mean, basically this one, but it will be a wolf idle and not a run. So wolf idle. We'll also assign the velocity dot x to 0 and the velocity dot y to 0. Now comes the more tricky part, and that is what about these things are, I mean, not within the threshold. So when we are moving, so what do we need to add? So what we will check is what is the current velocity. So velocity dot x should be direction dot x times the speed of x, and velocity y, it should be the direction of y times the speed of y. So what this means is if we have this one, so it is a target position minus global position, and we are normalizing it. So ideally this will be in between -1 and 1. Um, we can basically print this one, print the direction, and take a look like what we are getting. So if we run our wolf scene only and take a look at the console, I think here we will not have that. Um, So let's run our main scene once again. Here, so as you can see, we are getting the print value for our direction. So this will be generally between the +1 and -1, and we are multiplying it with our speed. So for our 4 direction movements, we have a speed of 200 and 100. But when we are moving in any direction, we have to take care of the speed also. We cannot move with this speed in any direction. And so we are normalizing it with the between +1 and -1, and then accordingly we are multiplying with the magnitude of the speed, like 200 and 100, and we are getting speed in different directions. So now we have to do some mental math. We will take the absolute value of the direction of x if this is greater than the absolute value of the direction dot y. In this case, if the direction regular direction dot x is greater than 0, I want the animated sprite to be running in the northeast direction. Otherwise, I want the animated sprite to be in the opposite direction. Now think of it for a while. If the direction of x is greater than the direction of y, which basically means is our x value is more than y. The orientation of the player in the x-axis. Like if you think about it, or it's better. Let's just run our code and then we will see. So let's also do the second part. And else, if the opposite happens, if the absolute value of y is greater than the absolute value of x, then also we will have something like this. But for our y, so if the direction of y is greater than 0, we will run in the southeast direction. Otherwise, we will run in the northwest direction. Now, even after doing so many things, it will not be accurate because ideally we should be having something like an 8 direction or multi-direction movement, but we only have 4. But yeah, this is better than nothing. So if I run once again, and let's try to run it like this. So as you can see, it is kind of trying to calculate that what is the like what direction it should take. And this can be better, this can be made better. This will not be as accurate as the keyboard movements, but the best way to make it better is having more sprite sheets with more directions. But you kind of get the idea that we are clicking on this one and how our player is moving. Now ideally this one should be even lesser. In our script, this move threshold, ideally I think it should be 1. Already the wolf is basically stopping at a good distance from where we are clicking. So let me just click it here. Actually, it is not that problematic because when we are looking at the map, our cursor is also seeming to change. Like it is not changing, but it looks like it is changing. And so, but yeah, actually the wolf will come very close. So let me just click on this patch of sand or rock or whatever. Yeah, it's almost going there and standing over there. So yeah, so this is working perfectly fine. Now the last thing that we need to add is something like a randomizer. So right now, this is our map, which is fine. This map is very good. But consider we want different maps every time we are playing the game. That is something that will be much, much better. And let's see how we can do that. And that is very simple actually. We just need to add a canvas layer to our tile map layer, and then we will add a button. This button will be the randomized button that will basically generate our maps. And now, in our tile map layer, I have to add a script. This script will be saved in the scripts folder once again. So, randomize, isomap randomize. Let me just name it like this: isomap randomize. And let me create this script. And we have already created a script like this for our regular tiles. Not for this one, I believe. Which is the other one? Which is the other one? Yeah, this one. Oh, this is the scene. I think I have to check the script. So in the script, huh. So this is our tile map layer that we are generating procedurally. So we have to take altitude and moisture, and we can also take temperature. We have to define our tiles. We have to define some width and height. We can take some terrain data. Uh, we may not need this for our ISO map because the terrain data is actually connecting with our tree layer, which is the second level of layer for our trees. But here we don't have trees, so we won't need a terrain data. we have to initialize our noise. And then we have the ready function where we will initialize our noise and generate our map. And in our map, we will basically loop through our map width and map height. And we will select some tiles according to conditions of altitude, temperature, and moisture. And using the set cell, we can basically set our cells. So let's quickly do this thing for our ISO map. Now, to do things fast, I will prefer to simply copy this whole function uh, apart from the button crest, because that is a signal that we need to add specifically. So we'll copy everything from the tile map layer into the ISO map. Let me just paste everything here. Let me remove this comment. I think it's not required, but other things will be as it is. Now, there are a few differences that we need to take care of. And that is for our ISO map, if we go to the tile map layer, and if we check the grass tiles, the 0, 0 and 1, 0 is not a grass tile. This is more like a rock tile. So the grass tiles are these three. So what we can do is we can just change it to 0, 2 and 1, 2. We can add more later, but our code will work like this. So I'm just using these two tiles. And if I'm taking the water tile, if this is not a 0, 1, we can take this one, which is basically 0, 10. So we can add the 0, 10. And lastly, we need a rock tile. And the 1, 1 is not a rock tile. You may consider this to be a rock tile also, but let me take a different rock. Let me take this one. This looks more interesting. So this is 1, 5. Now, one more thing that I want to do here is I have the altitude and moisture, but the convention is to use another variable called temperature. So we'll use a fast noise light.new. This doesn't change many things. So we have a map width and map height. That is fine for now. We don't need a terrain data, as I said, because we are not having trees in a different layer. So let me just remove this prints, not really required. What we can do instead is we can generate a temperature value equals to rand I. Okay. Now in the ready, we are generating our noise and generating our map. Now there is another convention instead of the map. Sometimes we also write generate chunk. So we can write a generate chunk here. We are getting the tile position, initializing it to 0, 0. Then we are looping through our width and height. We are getting map X and map Y. We are getting the value of moisture, altitude, and let's also take the temperature because we are taking it for this one. Temperature curve. We'll take it from the temperature dot get noise 2D. And we'll pass the map X and map Y times 10. Generally, these noise produce a value between -1 and 1, but this will produce a value between -10 and 10. Now we have coordinates. Now, if the altitude is less than 2, we are having a water tile. And if this is greater than 2 and the moisture is greater than 5, we are using a rock tile, but what we can do instead is if the altitude is simply greater than, so the altitude can be between -10 and +10, right? So this value. So I think less than 2, we can just keep it less than 0. If this is, let's say, greater than equal to 0, um, let me just take it like this. If this is greater than 5, then we want a rock tile. And otherwise, we want grass tiles. Elif altitude curve. What kind of error we are getting here? I think this is fine for now. Okay. And lastly, we will take the grass tiles randomly. And now we are okay. So this is an error because we have removed. There was a terrain data that we were storing for the next layer of maps. So this is something that we can remove now. And then we are setting the cell with the coordinates. Now we also need to add a signal for our button. So we'll just take the button and we will add a signal. It should be connected to the tile map layer. And what we want to do here is whenever we are pressing the button, we just want to do these two things. So let me just keep it here. And now if I run my ISO map once again, we will see something very, very interesting. And that is a huge map has generated below, and this can be changed like this. So this is our original map, which is in its place. And yeah, so this looks a little bit weird because we also have an original map. So if I simply remove the original map, which I don't want to because it looks good, but yeah, only to show you, if I just remove this map, so I have to go to the tile map layer, tile map, and click on the rectangle and here we can basically remove the whole map. So like this, I believe. Yes. Huh. So the whole map is removed. Now if I just start a game, we have a random map and we can randomize it like this with different maps. Now you may feel that, okay, so the rocks are also coming. I think it's good. We can make it better. Now you may feel that it doesn't have a lot of tiles, but yeah, you can always add more tiles. And a better example is our open world. So in our open world, if I just check the script, and this is our open world script, and here we were taking the altitude and other things. And if we simply check the open world tiles, we have a 16 tiles. And how are we using the tiles? So we are checking the altitude. If this is low, we are randomizing our tiles. And if this is, let's say, less than 0.2, we are taking only the fourth column, which is only our water tiles. So low altitude means water. So similarly for our ISO map also, if the altitude is less than 0, it is a water tile. So yeah, so that is the thing that we are doing. Yeah, you can basically take inspiration from this one to use more and more tiles, but this is a basic idea of how we can use like isometric tiles to create a randomly procedurally generated isometric map. So that's it for this video, folks. And if you have learned something new in this video, make sure to like, share, and subscribe the channel. It helps me grow it fast. And if you want to talk with me regarding tech or game dev or AI or anything for that matter, you can always join my Discord server. I will keep the link in the description below. And I will see you soon with another very interesting video. So see ya.